咁多位大家好，我係梁 Sir。今日呢段片呢，我哋就主力去溫一溫人類嘅循環系統。呢個呢都係一個好熱門嘅課題嚟嘅，因為佢個維度其實好大嘅，由血管啦、血嘅細胞啦、物質嘅交換啦、組織液嘅生成啦、淋巴液啦，林林總總。咁所以大家都一定要溫一溫呢一課咯。咁今次咧就主力想同大家溫下有關於組織液嘅生成啦、移除啦，同埋物質交換嘅概念嘅。咁當然啦，我哋就不得不講嘅就係呢三類型嘅血管啦。咁而家我哋見到呢幅圖啦，就係話咧不同血管嘅排列。咁中間咧就係我哋嘅微血管啦。咁左右兩邊啦，由心臟帶啲血嚟嘅就係動脈啦，同埋將啲血帶翻去心臟嘅就係靜脈啦。咁我哋三款血管有晒啦。然後題目就講咯，喺呢幅圖入面呢，我哋有兩類型嘅箭嘴，黑箭嘴同埋白箭嘴。咁佢哋就分別代表咗兩個控制啲流體係進出微血管網絡嘅兩個因素。咁究竟呢兩個因素係乜嘢呢？咁自不然啦，呢條題目就考翻我哋有關於組織液嘅生成啦、移除啦嘅機制係如何咯。咁望翻呢幅圖啦，咁我哋都會發現得到啦，由小動脈帶啲血去到個微血管嘅開端嘅時候呢，咁分支咗好多條啦，係咪？咁其實白箭嘴同黑箭嘴分別就係講緊第一，小動脈帶啲血去到微血管嘅開端嘅時候呢，喺個血入面嘅流體靜壓或者個靜水壓呢，係高過包圍住我哋嘅身體細胞嘅組織液嘅壓力嘅。因為組織液其實都係液體嚟噶嘛，而血其實都係流體，都有個壓力嘅。咁今次我哋就唔係講血壓，我哋講嘅係血入面嘅液體，所以係流體液壓或者我哋嘅水壓或者靜水壓啦。咁所以白箭嘴你會發現啦，佢就係由微血管出咗去組織液嘅，所以白色箭嘴就代表住血同埋組織液之間嘅流體靜壓嘅差別啦。然後就去到黑箭嘴咯，你會發現佢係入翻去個微血管嗰處嘅。咁無論係喺 P 呢邊啦，定係 Q 呢邊都會翻到去嘅。咁原因又何在呢？呢個就考緊我哋組織液嘅移除啦。由於血漿蛋白 plasma protein 呢，佢哋好大粒，佢係唔能夠喺呢個小動脈嘅末端呢一邊呢被逼出嚟嘅，佢哋係離開唔到個微血管，所以佢哋仍然喺個血入面啦。而 plasma protein 血漿蛋白係溶到落水嘅，佢就會令到近小靜脈嗰邊嘅微血管入面嘅血呢，嗰個 water potential 水勢係會低咗一啲嘅，低咗梗係唔係大晒啦。而家我哋講緊係嗰啲組織液係會翻去個血管度啊嘛。所以發生嘅就係組織液入面嘅水分就會被抽翻去微血管，而當中嘅過程就係 osmosis 滲透啦。咁滲透係用乜嘢嘅因素所去控制住噶？自不然就係水勢嘅差別啦。咁所以黑色箭嘴就係代表住喺個血入面同埋組織液入面佢哋之間嘅水勢嘅差異啦。答案兩句其實一樣嘅 ，difference between water potential 或者 the water potential gradient 水勢嘅梯度其實都係可以接受嘅。好，跟住嚟到 part B， 考生表現較為差嘅題目就問啦，原來呢啲箭嘴嘅大細呢係代表住嗰個因素嘅影響力嘅幅度啊，即係究竟係大啲影響力啊，定係細啲影響力啦？咁你見到大嘅白色箭嘴，細嘅白色箭嘴嘅。咁而家題目呢都係想講白色箭嘴啫。佢就問啦，當啲血由 P 流去 Q 嘅時候，即係由動脈流去微血管、流去靜脈嘅時候啦，咁究竟呢個白色箭嘴呢個因素個力度有啲咩變化呢？咁呢一條題目就考翻我哋嗰個因果嘅關係啦。咁最首要啦，睇翻白色箭嘴先啦。白色箭嘴有咩咁特別呢？原來你會發現啦，原來近動脈嗰邊嘅近阿 P 呢邊嘅白色箭嘴呢，佢係比起近 Q 嗰邊嘅白色箭嘴呢，係大過啲嘅。去翻頭先 part A 我哋去講嘅白色箭嘴就係講緊啲血入面嘅流體靜壓係比起組織液嘅流體靜壓為之大力啊嘛，所以血入面嘅血漿就會被逼出嚟啦，連埋水分啦、葡萄糖啊、氨基酸啊諸如此類嘅物質啦，你會發現去到 Q 嘅時候呢，佢都會出去，不過就細力啲嗱，所以呢度呢就提翻大家一個概念啦。我哋嗰個組織液嘅形成同埋組織液嘅移除呢，佢唔係有與冇嘅問題嚟噶。 其實係多與少或者快與慢嘅概念嚟噶。咁呢一條題目呢，佢就幫你深化少少呢一 part 嘅邏輯咯。咁啊，除咗書嗰幅圖啦，咁啊呢一幅咧都係筆記常用嘅。咁啊，由一邊嚟嘅係動脈去到微血管，咁逼咗出嚟嘅就係一個組織液啦。呢個虛線嘅流向就係組織液嘅生成啦。跟住啦，啲血又繼續向前行嘅。即係所有嘢其實啲液體咧係冇一刻停止過嘅，大家都係行緊噶。咁而家我哋要解決因果關係啊嘛。咁其實個因咧就係考翻喺近小動脈嗰邊嘅微血管，佢係如何生成到組織液，係生成得多一啲嘅。跟住啦，去到個結果呢，頭先啱啱知道咗啦。近小靜脈嗰邊嘅微血管呢，喺1、2、3、4，而個果呢，就係頭先啱啱我哋講近靜脈嗰邊發生嘅事啦。原來啦，喺血同埋組織液之間嘅流體靜壓，佢哋個相差呢係細咗嘅。咁而家我哋整條題目嘅思考邏輯係點樣去理解呢？我用翻右上角呢幅圖啦，望一望咯。當啲血由小靜脈將要進入到微血管嘅時候，其實嗰條路呢係由大變細嘅，即係大路入細路啊，係咪啊？咁即係條路咁窄嘅時候呢，好似我哋玩水喉咁嘅款呢，其實嗰個阻力好勁啊嘛，啲水好似想逼出去噶嘛，係咪？咁啲血由小動脈去到個微血管嘅時候，個血壓係升咗少少嘅。咁但係呢一樣嘢，喂，冇書冇講過，啱噶。咁啊，因為啦喺呢一度都會發生一件事，就係嗰個液體1、2、3就係咁啊。當個血由小靜脈入到去微血管嘅時候，血壓係有少少嘅上升嘅，而喺呢個過程底下就會將血液入面嘅流體啊1、2、3、4血漿啊、水分啊就會逼咗出嚟，從而啦就導致到微血管入面嘅血嘅體積就會點樣呢？就會減少咗，即係話喺血管入面嘅血液係少咗，血壓都會低咗，所以啦喺個血入面1、2、3，所以啦當啲血沿住個微血管一直行嘅時候呢，其實啦佢哋嗰個血1、2、3、4，其實血入面嘅流體靜壓或者個血壓呢都係下降翻嘅。1、2、3、4，咁所以呢個亦都係切合翻我哋平時書本學嘅概念噶嘛。喺動脈嚟嘅血個血壓係最高嘅，去到 capillary 微血管嘅時候就低咗好多，再去到個1、2、3，再去到靜脈嘅時候啦，又再低一啲。咁啊，因為啲血已經要克服咗重重困難、重重血管嘅阻力，所以佢個1、2、3、4，所以個血壓咧去到靜脈就極低啦。咁除咗呢一個1、2、3呢個思考邏輯嘅寫法之外啦，咁答呢啲因果關係呢，你可以先答因後答果，又或者你可以先答咗個果再去解釋都得嘅。咁因為當啲血去到近小動脈嘅微血管嘅時候呢，佢哋就會被逼咗出嚟，微血管入面嘅血液嘅體積呢就會減少。咁所以你會發現啦，1、2、3、3、2、1都係咁樣答嘅啫。好，跟住啦，去1、2、3、4，跟住啦，我亦都想借呢個機會咧，去解釋翻之前同學仔問嘅題目嘅，就係乜嘢叫做流體靜壓或者咩叫靜水壓呢？喺個血管入面，究竟呢個壓力係咩意思呢？咁好快解釋翻咯。流體靜壓嘅意思呢，就係當一個液體喺一個平衡嘅狀態底下，喺任何時間點被施加嘅1、2、3、4。1、2、3、4，流體靜壓嘅意思就係由於重力嘅作用，即係我哋嘅地心吸力啦，體喺平衡嘅狀態底下，喺任何時間點所施加落嚟嘅壓力。咁你話睇完呢句都唔知咩意思，俾幅圖你睇下，其實就係講緊喺呢個杯呢，咁我哋裝滿晒水啦，咁我哋開3個窿，第一個窿、第二個窿、第3個窿，咁原來啦，我哋會發現呢個靜水壓或者呢個流體靜壓啦，佢係同嗰個從表面所測量嘅深度呢係成正比嘅。所以你發現啦，水面咧個壓力係低一啲，越落越底咧個水壓係越高嘅。咁呢個就係流體靜壓嘅概念，亦都以一個重力嘅角度去理解。但係啦，而家喺血管兩 Sir 重咩力啊？所以啦，流體靜壓有另一個嘅概念，就係流體靜壓除咗係由重力所去導致之外，亦都可以喺一個封閉嘅容器入面嘅加速或者作用力所引起嘅。我哋嘅循環系統、運轉系統就係一個密閉嘅系統啦。你諗下，我哋嘅血管啦、心臟啦，全部係接駁住一齊嘅，係一個閉合嘅系統嚟嘅。而我哋個心臟泵血泵嘅時候，係咪就有一個加速度或者一個力去拱啲血去行啊？所以啦，當我哋心臟收縮嘅時候，就會提供一個 pumping force 泵送嘅力量，去將啲血驅動去到個動脈嗰個位。所以啦，點解喺小動脈 入到去呢個微血管呢個位置嘅時候，佢就有一個大咗嘅流體靜壓出現啦。流體靜壓呢就係大力咗啦，而大力過邊個啊？係個血液入面嘅液體，例如個血漿啊、水分啊，佢哋個流體靜壓係大力過喺個組織液嘅流體靜壓，即係 hydrostatic pressure， 所以啦，喺個血管入面嘅嘢就會被逼咗出嚟啦。仲有一個好關鍵嘅概念，就係因為微血管佢個血管壁係點樣噶？係差異透性啊嘛，一啲細細粒嘅嘢係可以出到嚟噶嘛，所以水分啊、葡萄糖啊、氨基酸啊、鹽啊嗰啲咪出到嚟咯。呢個呢就係流體靜壓嘅概念啦。跟住啦，去到 part C 咯，咁佢就講翻啦，原來咧呢個微血管呢，就係喺個血液同埋組織液之間攞嚟做物質交換嘅地方嚟嘅。而當我哋啲血去流經一個特定器官嘅微血管網嘅時候呢，某一啲嘅物質就會被吸收去到個血嗰處，然後被帶走嘅。因為啲血一直都係由個動脈去到個微血管，去到個靜脈噶嘛。咁所以呢個概念呢就冇得走雞噶啦。咁所以呢個概念呢就冇得走雞噶啦。咁題目就問我，下面呢我哋有兩款嘅物質，一個係胰島素啦，一個係尿素啦。咁要我哋指出同埋解釋下喺個微血管網究竟佢喺邊個器官嗰度出現。咁啊，第一部分呢，佢做咗個例子俾你嘅，喺某某器官入面，當啲血流經咗呢個微血管網之後呢，佢就會吸收咗當中嘅胰島素。咁啊，因為胰島素就係由呢個器官所去分泌出嚟，好啦，係對我哋嘅血糖水平作出反應。咁呢條題目自不然就係考緊我哋啦，胰島素同埋尿素究竟佢哋喺邊度製造出嚟啦？唔使審啦，胰島素梗係由個胰臟啦，係咪？咁尿素又由邊度嚟啊？就係由個肝臟所去進行嘅脫氨作用啦。所以答案就係 liver 啦，肝臟啦。因為肝臟嘅細胞就會將額外多餘嘅氨基酸呢，就進行脫氨作用，將佢轉化成為尿素，同埋啦，剩餘嘅部分就會變成碳水化合物同埋呢個脂肪啦。咁但係今次呢句就唔使講嘅，因為主角淨係講尿素啫。咁過完嚟呢度啦，啲尿素就入咗去個血，然後就被靜脈帶離開個 liver 啦。咁啊，今次佢冇問你啲血管名啫，下次咪問下嗰啲 hepatic vein 啊、肝靜脈啊呢啲咁嘅概念啦。咁過往呢，其實都有考類似嘅題目噶，例如啦 AirSac 呢一條呢，就問下啦，喂，當啲血流經咗個氣囊之後啦，咁佢嘅氧氣啊、葡萄糖啊、尿素啊嗰啲嘅水平有冇咩變化呢？咁過往都有啲血管嘅邏輯學嘅，其實都係考緊類似嘅東西。咁啊，快啲睇下片溫下書咯。然後啦，就嚟到一點出發啦。今次嘅題目呢，就由微血管開始啦，就問翻組織液同埋物質交換嘅概念啦。組織液嘅話啦，呢度提翻大家咯，微血管有咩適應性特徵呢？喺個身體嘅組織當中呢，小動脈就會分支變成咗一個微血管網啦。然後啦，微血管係有幾窄啊？只係輕微地大過一個紅血球嘅直徑啫，即係話啦，啲紅血球呢，要逐個行嘅。同埋啦，微血管壁咧，佢係 one cell thick 好薄啦，導致到嗰個擴散嘅距離 diffusion distance 係好短啦。同埋啦，佢係差異透性，即係細粒嘅嘢可以走，大粒嘅嘢就走唔到啦。咁所以啦，紅血球走唔走到啊？白血球又走唔走到啊？血漿蛋白又走唔走到啊？呢啲問題我相信大家都一定會識噶啦。然後啦，組織液咧又要講形成或者移除，咁過往都有關於組織液嘅成分啊嘅題目嘅，點樣錯佢出嚟啊？點樣整翻走佢啊？咁啊，快啲睇下片，溫下書啦。當中咧就有兩隻字，今次題目零零舍舍考我哋嘅，就係水勢 water potential 啦，同埋流體靜壓hydrostatic pressure。咁啱啱亦都解釋咗呢隻字啦。然後啦就去到物質交換，咁啊物質交換咧當中有用嘅嘢啦，有廢物啦，有激素啦，諸如此類。而當中咧，你話喂，係咪全部嘢都要死記啊？梁 Sir，梗係唔係啦。以前拍過段片咧去解釋俾大家聽，透過血流方向，其實所有嘅器官、所有嘅血管，你都已經知道晒究竟入面運緊嘅係啲乜嘢嘢，多唔多氧氣， 多唔多二氧化碳？一條片搞掂晒，咁啊快啲睇一片溫下書咯。咁當中啦，除咗血流嘅方向，亦都有器官嘅個別嘅功能啦。係咪攞嚟吸收養分噶？係咪攞嚟分泌荷爾蒙啊？去做體內平衡啊？諸如此類啦。然後啦，結合埋就問翻血液嘅成分啦。除咗血液成分之外啦，其實仲可以問下血壓噶。所以呢幅圖啦，你又識唔識得解呢？點解喺個 artery 動脈佢嘅血壓係咁高，仲要有一個脈搏高高低低嘅概念呢？然後去到微血管就低，去到個小靜脈，去到靜脈就更低。而同一時間個血流速度又如何呢？你又識唔識得解呢？Student, I'm Mr. Leung. So in this video, we are going to do the revision about the human transport system. So the human transport system is a very hot topic because it contains a lot of concepts: blood cells, blood vessels, tissue fluid, the heart structure, a lot. In this video, we focus on the tissue fluid formation and removal, and also the material exchange. So let's take a look at this diagram. So it shows the arrangement of some blood vessels. We have the artery, bring the blood from the heart, and we have the vein, carry the blood towards the heart. And then in between the artery and the vein, we have the capillary network. So when you are seeing this diagram, I expect that this diagram from the textbook pops up in your mind, so that you understand the blood flow direction and understand the question. The two types of the arrow, black and white, represent two factors which govern the movement of the fluid into or out of the capillary network. So, in this question, we need to identify these two factors. So, for this question, surely it's checking us the concept about the mechanism of formation and removal of the tissue fluid. So, let's go through the concept. So, we focus on the arterial end of the capillary bed. The hydrostatic pressure of the blood is higher than the pressure of the fluid surrounding the body cells. So you know that for the airflow, for the blood flow, for the water flow, it's governed by the pressure difference. So we can see that the hydrostatic pressure of the blood is higher than the pressure of the fluid surrounding the body cells. So this force some component of the plasma, for example, water, glucose, amino acid, they are forced out of the capillary wall to form the tissue fluid. Therefore, for the white arrow, it means the difference between the hydrostatic pressure of the blood and the tissue fluid. What about the black arrow? The black arrow, it goes back to the blood, right? So it means the removal of the tissue fluid. As the plasma protein, they remain in the blood of their big size. They are just too big to be forced out from the capillary. They stay in the blood, and then it will lower the water potential of the blood at the ventral end of the capillaries. So the water potential is lower, is not enough. The water potential is lower than that of the tissue fluid. Therefore, the water in the tissue fluid is drawn into the capillaries by osmosis. So what is the factor governing the osmosis? Surely it's about the water potential. Therefore, the factor is the difference between the water potential of the blood and the tissue fluid. Or you can say that the factor is the water potential gradient between the blood and the tissue fluid. So you never part B. In this question, the performance of the candidates is not that good. So it asks that the size of the arrows in the above diagram represent the magnitude of the factors. Is a higher degree or lower degree to govern the movement of the fluid out of the capillary or go back into the capillary. So we need to explain the change in the factors denoted by the right arrow as the blood flow from the P, that means from the artery, to the Q, to the vein. So in between, we have the capillary, right? So I'll pass from the diagram from the textbook. So I also use the diagram in my notes. For this question, it's checking us the skills to explain the cause and effect relationship. So the cause and effect, in this diagram, we can take a look at the effect first. Because the change in the factors, we can simply see it from the diagram. Based on part A, the white arrow represents the hydrostatic pressure of the blood in the capillary, and in the diagram, the critical findings is that the white arrow near the P are bigger than those near the Q. So you can see that the yellow highlighted arrow and the green highlighted arrow, So it means that the factor represented by the right arrow or the hydrostatic pressure decreases as the blood flow from P to Q. So in this part, I also would like to mention the philosophy of biology again. So when we are studying biology, it's not always the matter of yes or no, but the matter of high or low, fast or slow, something like this. So you can see that for the formation of the tissue fluid, it does not just take place near the P, but also the Q. But just the magnitude is different. The rate of the formation is different. And then for the cause and effect, what's the cause? The cause should be the formation of the tissue fluid at arterial ends of the capillary. And what is the effect? I have already known. Decrease in the hydrostatic pressure gradient between the blood and the tissue fluid. And then what is the thinking logic? Firstly, we need to talk about the blood flow at the arterial end of the capillary. And we need to realize the fluid movement. So when the blood they go through the arterial end of the capillary, the blood pressure will increase a bit. And then the fluid, the plasma or the water from the blood is forced out from the capillary at the end near the P. And then we need to determine the consequence for the blood volume in the capillary. So in the capillary, because the plasma, they are forced out from the blood capillary, the blood volume in the capillary will decrease. And finally, because there is smaller blood volume in the capillary, leads to the decrease in the factor represented by the right arrow or decreased in the hydrostatic pressure or the blood pressure. So we have the 2 marks for the cause and 1 mark for the effect. And from the effect, you can just find it from the diagram. And apart from this thinking logic, 1, 2, 3, and then can we start from the effect first? Surely, we can talk about the effect first. Firstly, we talk about there is a decrease in the factor represented by the right arrow or the hydrostatic pressure. It becomes smaller. And then what is the reason? It's because the fluid, plasma, water is forced out of the blood at the end near P. So the blood volume in the capillaries decreases. So you can see the variation of the answer presentation. And I would like to grab this chance to explain what is hydrostatic pressure. So for the hydrostatic pressure, for the simple definition is that the pressure exerted by fluid at any point of time due to the force of gravity. And surely, by this definition, you may not understand it that well. So I give you this diagram. You have a beaker full of water, and then I open 3 holes, the upper one, and the middle one, and the lowest one. So you can find that the hydrostatic pressure is proportional to the depth measured from the surface. So you can see that. So on the upper part, the shallow part, the hydrostatic pressure is lower, and then in the middle is a bit higher, and on the bottom is the highest. Pressure increases with the depth. In this case, we use the beaker as the metaphor to show the difference of the hydrostatic pressure. However, it's about the transport system, Mr. Leung, the blood in the blood vessels. So elaborate a bit for the transport system. The hydrostatic pressure can be caused by gravity and also by the acceleration or the forces when in a closed container in our transport system, which is a closed system, because you can see that the blood vessels and the heart, they are all connected together. It's a closed system. And for the heart, and for the heart, when the heart muscle contract, it will generate a bumping force. This force can also create the hydrostatic pressure. Therefore, contraction of the heart provides a bumping force to drive the blood to the arteries. And to the arteries, you will see that at the arterial end of the capillary, the blood pressure will increase a bit. And then the hydrostatic pressure of the blood in the capillary is higher than that of the fluid surrounding the body cells. That's the reason for the formation of tissue fluid. And lastly, we talk about part C. The capillary network is the location where exchange of the material occurs between the blood and the tissue fluid, and when blood flows through the capillary network of a particular organ, some substance will be taken up into the blood. And we need to state and explain the organ where the capillary network is found. In this table, we have the insulin and the urea as the substance taken up in the blood. The blood, they are pumped by the heart and then carried by the artery to the capillary and then back to the vein and then back to the heart. And the blood go through the capillary, they will take up something in that particular organs, right? So for insulin, it say that insulin is secreted from this organ in response to the change of the blood glucose level. So for this question, surely is checking us the concept about the location for the production of insulin and urea. And for part 1, very straightforward question. Pancreas is the answer, right? Because insulin is secreted by the pancreas. And maybe next time it can ask you glucagon. And then for the next part, part 2, we need to recall the process which need to production of urea, which is the deamination by the liver. What's the explanation is that the excess amino acid are deaminated or are broken down by the liver to form the urea. And in the past, there were different questions about such material exchange. So in 2015, this MC question, it asks you that when the blood flow through the air sac, what will be the change of the oxygen content, glucose content, and the urea content. Very similar concept for the umbilical cord logic and the gas exchange logic. So watch the video to do the revision. And let's talk about the curriculum mapping. Question starts from the capillary and then asks us about the tissue fluid and the material exchange. For the tissue fluid and capillary, surely I need to recall the idea of the adaptive features of the capillary. The lumen is very narrow, just slightly larger than the diameter of a red blood cells, and the wall of the capillary are just 1 cell thick, shorten the diffusion distance, and the capillary wall is also differentially permeable. The small substance they can pass through, and some cells, for example the red blood cell, they are too large, they cannot pass through the capillary wall. So I assume that you are familiar with such adaptive features. And for the tissue fluid, surely we need to talk about the formation and the removal of the tissue fluid. So watch the video to do the revision. And in this question, we talk about the water potential and the hydrostatic pressure. And for the material exchange, not just about the useful substance, but also the metabolic waste and the hormones. So how can we determine the level changes when the blood passes through a particular organs? Actually, is related to the blood flow direction. Do you need to remember everything? No. You can watch this video to use the guiding question to understand everything, to grab the idea back. So for the material exchange, it depends on the organ function, for the absorption, for the secretion, or for the homeostasis. And then we combine the idea of the tissue fluid and the material exchange. We talk about the blood content. And apart from the blood content, next time it may ask you about the blood pressure or the blood velocity. So you can see from this diagram, for the blood pressure, it keeps changing along the blood vessels. From the arterial is higher pressure and with the pulse, and for the capillary, for the vein, the blood pressure, it goes lower and lower. So can you explain the idea behind this phenomenon? So I hope that you're familiar with this concept.